Hi everyone! Hope you're all having a fantastic day. It's going to be a beautiful day today. It's going to be a beautiful weekend, actually. A little bit of information up front here. We are going to be talking about sine of a plus b and cosine of a plus b. Now, this is what's going to happen when you are trying to take the sine or the cosine of two angles added together, right? Two angles, angle 1, angle 2 added together. Now there's a special way that we have to do this. And to illustrate that point, let's take a look at number 1. It says cosine of 30 degrees plus 60 degrees. So let's actually figure out what this is going to be here. I'm going to split this up, and what the question is asking, does the cosine of 30 degrees plus 60 degrees equal the cosine of 30 plus the cosine of 60? Now, way back in your algebra days, in a land far gone of myth and legend, in the days of algebra, when dragons were real and stuff, what it's asking is, can you distribute cosine? Really, if you look at it here, it's saying, can I take this little cosine guy right here and put him here and put him here? That's what it's asking. Let's figure that out. What's 30 degrees plus 60 degrees? Well, that's the cosine of 90 degrees, isn't it? And if there's anything we know about 90 degrees on our unit circle here, that the cosine of 90 degrees is 0. Okay, what about cosine of 30 plus cosine of 60? Well, what's the cosine of 30 degrees? It's the square root of 3 over 2. Plus, what's the cosine of 60 degrees? It's 1/2. Right? Cosine of 30 and cosine of 60. So you add those together and you get square root of 3 plus 1 over 2. Is that 0? No, that's not 0. So here's what I want you to write down off to the side here. You cannot distribute trig functions. My writing is horrible today. Goodness, forgive me for that. You cannot distribute trig functions. You can't distribute them. It can't be done. So we saw this, not we, I wasn't there. Some mathematicians a really long time ago saw this and they thought, well, this is a problem because what if these are variables like a and b? And we need to come up with a way to simplify it. So they did some calculating and they did some measurements and some stuff, and they came up with the sum and difference formulas. Sine of a plus b is sine a times cosine of b plus cosine of a times sine of b. Okay? Sine of a minus b is the same thing, just with a minus sign in there. Now these two, on their own, these two are pretty easy to remember. It's just sine a cosine b plus cosine a sine b. What they're saying is that the sine value, the y value of a plus b, is the y value of a times the x value of b plus the x value of a times the y value of b. It's kind of like you're taking all of the parts of these points into play. There's a fly flying around my room, and it is driving me insane. So if I catch it, sorry. So sine of a minus b is sine a cosine b minus cosine a sine b. I won't have you memorize these. I'm just going to have you use them for now. And eventually you'll memorize them just kind of by default. The same way you did with the Pythagorean theorem. You used it so much you just remembered it. Same way with these. Cosine of a plus b is cosine a cosine b minus sine a sine b. This one's different because the plus sign with cosine makes you have a minus sign. Cosine of a minus b is cosine a cosine b plus sine a sine b. So again, you don't need to spend time memorizing them, but you will eventually memorize them just by default. Okay? So here's how we use these. Number 2 says to simplify 2 cosine, or excuse me, cosine of 3x, cosine of 2x, plus sine 3x, sine 2x. What I'm going to do is take this and I'm going to look up here and I'm going to say, does this format fit anything I have up here? I'm looking for a cosine, cosine, plus sine, sine. Sorry, I missed him. He was there momentarily. Ha, he flew away. Okay. Wow, it zoomed in even. Sorry. Cosine, cosine, plus sine, sine. Cosine, cosine, plus sine, sine. So the value of A here is 3x. The value of B here is 2x. So that will simplify down. If I use this formula, it's cosine A cosine B plus sine A sine B. That will simplify to the cosine of A, 3x, minus B, 2x, which is cosine x. Please don't overthink this. All you're doing is looking at these formulas and basically simplifying, going back. Okay? So down here, number 3, sine 105 cosine of 15 minus cosine 105 sine 15. Sine cosine minus cosine sine. Sine cosine minus cosine sine. It's sine of A minus B. That's going to be the sine of 105 minus 15. Let me scoot that up here. And that is going to be 105 minus 15 is the sine of 90 degrees, which is 1. Okay? So it's a way to simplify these really complicated problems. Okay. So let's get on to number 4 here. Now number 4, this gets pretty interesting here. It says, suppose that sine of alpha, so now we're at a reference angle again, is 4 over 5. Sine of theta is 5 over 13. So I've got 2 angles, alpha and theta. Now keep in mind that these are not necessarily related, okay? They're 2 different angles. All I'm giving you is just 2 different angles, okay? And then it says that, let me zoom out here just a hair. Alpha is somewhere between 0 and pi over 2. So let's graph alpha. Here's how alpha is going to look. Alpha is somewhere between 0 and pi over 2, which is here. So here's alpha. And it says sine is 4 over 5. Well, sine was y over r, right? Y is 4, r is 5. Using a little Pythagoras, we can come up with this as 3. Okay? And then it says that sine of theta is 5 over 13, and theta is between pi over 2 and pi. So that's in the second quadrant, pi over 2 and pi. Up here. Okay, so here's theta. And it says that theta is sine of 5 over 13. So that's 5, that's 13. Using a little Pythagoras, this is 12. So I want you to look at what we've got here. Before we even get into the question, we have got 2 angles, one alpha, one theta, and they gave us sine values of 4 over 5 and sine values of 5 over 13. And they're going to ask us basically to use all 3 parts of these triangles, your sines, your cosines, and so on. So let's look at what the question is actually asking us now. It says, find the value of sine of alpha minus theta and cosine of alpha minus theta. Okay, this has the the ability to get kind of complicated, so I want to take this really slow. Let me go up here. First, I'm going to find the sine of alpha minus theta. What you may want to do is just watch for this first part, and then you can go back and you can press pause and go back and write all this stuff down. You may just want to watch this first go around. So sine of alpha minus theta. I'm going to go back up to the top here, and I'm going to use sine of a minus b, and I'm going to expand this. Okay, I'm going to expand it to sine a cosine b minus cosine a sine b. Here's what it's going to look like. So the sine of alpha minus theta is going to be sine alpha cosine theta minus cosine alpha sine theta. All right, so now it's up to me to come up with the missing bits to this. Here's the reason I went ahead and labeled my x values. It's asking for the cosine of theta. Once you write down the formula, at this point it's easy sailing, because all you have to do is look at alpha. What's the sine of alpha? 4/5. Times, look at theta. What's the cosine of theta? X over r, 12/13. Minus, go to alpha. What's the cosine of alpha? 3/5. Go to theta. What's the sine of theta? Sine is y over r, 5/13. Again, this is the part we're finding right here. So that's going to be a little simplifying here. This will be 4 and 12 is going to be... Oh, I'm sorry, I messed something up here. I knew I missed something there. This is why I'm glad you watched. I've got to label this a -12 because it's in the second quadrant. So this will be negative here. Lots to keep up with. -48 over 5 and 13 is 65. Minus 15 over 65, which is -63 over 65. That's finding sine alpha minus sine theta. All right? Now let's keep going. We need to find cosine of alpha minus theta. So I'm going to come over here to do this one. Cosine of alpha minus theta. Again, I'm going to go to the top. I'm going to go to the top. Cosine of a minus b is cosine of alpha, cosine of theta, plus sine of alpha. I'm running out of room. Sine of theta. Cosine of alpha is 3/5. Cosine of theta, -12/13. Plus sine of alpha, 4/5. Sine of theta, 5/13, which is going to be -36/65 plus 20/65 is -16/65. Okay, so yes, these are going to be some of the more complicated questions. They are complicated. Okay, but it's not impossible to do. Let me back up a little bit here. Remember, I said sine of alpha minus theta, expand it, plug in. Cosine of alpha minus theta, expand it, plug in. Expand it, plug in. Expand it, plug in. Okay? Let's go to the back. Number 5. says that if sine of x equals negative 2 over 3, and it's somewhere between pi over 2 and 3 pi over 2, find the value of sine of x plus x over, wow, pi over 3 plus x. Sine is negative 2/3. Where will that put this thing? Negative 2/3. So sine is negative. That's in the third and fourth quadrant. And then pi over 2 and 3 pi over 2 is second and third. So the only place where those meet is the third quadrant. And your sine value is a negative 2 over 3. Little Pythagoras will tell you this is the square root of 5. But again, since you are in the third quadrant, your x is negative. So let's figure this out here. Sine of pi over 3 plus x. All right, let's expand it first. Remember that this, on the front page here, we have sine of pi over 3. Ooh, wow. Sorry. Sine of pi over 3 times cosine of x plus the cosine of pi over 3 sine of x. Now where, oh where, to get these values from? Pi over 3 is on your unit circle. X is the angle you just drew. Pi over 3 is on the unit circle. X is what you just drew. Okay? Okay. So a couple things here. We've got first and foremost here, let me pull this up. It's going to be equal to sine of pi over 3, square root of 3 over 2, unit circle. Cosine of my values over here are negative square root of 5 over 3. Plus cosine of pi over 3 on the unit circle is 1/2. Sine of x is negative 2 over 3. Told me right up here. Negative 2 over 3. Combined together, you get, what would this be? Negative square root of 15. Multiply the insides there. Over 6 plus negative 2 over 6. Which is negative square root of 15 minus 2 over 6. Just like that. So the only new thing here is the expanding it. Expand it, plug in. Expand it, plug in. All right. So let's talk about proving. Some proofs here. It says prove the following identities or verify the following identities are true here. So we've got cosine of pi over 6. Let's expand it first. That's going to be cosine of pi times cosine of x. Since it's a plus sign, we'll do minus sine of pi sine x is equal to negative cosine x. What's cosine of pi? Cosine of pi, the x value at pi, negative 1. Negative 1 cosine x minus, what's the sine of pi? 0. Well, won't that cancel out and make that just 0? So you have a negative, well, cosine of x equals negative cosine of x. That's not too terrible. Let's go down to the last one here, number 7. This one is interesting because you've got a cosine of x minus y. You've also got a cosecant x and a secant y. So first, let's expand cosine here. This will be cosine x cosine y plus sine x sine y. That came from the front equations there. Let's go ahead and change this. Cosecant is 1 over sine of x. Secant y is 1 over cosine of y. And this has got to equal cotangent x plus tangent y. Not changing anything on the side there. Well, multiply this through. You've got 1 over sine x multiplied through. You've got 1 over cosine x multiplied through. Blah, 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 blah. Okay. If we combine these together, you know what? Let's combine them together. That way it's just one step. This is 1 over sine x cosine y, right? Okay, let's multiply this to both of these. So I've got cosine x cosine y over sine x cosine y plus sine x sine y over sine x cosine y. Much better. Okay, so again, I combined these two fractions right here into one, and then I multiplied that through here and here. So your cosine y's will cancel, sine x's will cancel, and you've got cosine x over sine x, yay, plus sine y over cosine y, cotan x plus tan x, or tan y rather. And isn't that, I mean, cosine over sine is cotangent x plus sine over cosine, tangent y equals cotan x plus tan y. That's all there is to it. Ain't nothing to it but to do it. Alright? So the only thing that's different on this one, we call these the sum and difference formulas because you are summing, adding, and finding the difference, subtracting two angles.